Hi, for this video and for this example, what we're going to be doing is finding the exact area of the function f of x, in this case negative 2x minus 2, over the interval negative 4 to 3 using the definition of the integral. To begin, let's simply just remind ourselves what the definition of an integral is. So that is just going to be equal to limit as n approaches infinity for the summation of f of xi times change of x. So in order to evaluate our integral, what we're going to have to do is find our f of xi and our change of x first. Our change of x is simply going to be equal to, so change of x is going to be equal to our b minus a all over n. So that in this case is just going to be equal to negative 4 minus actually not negative 4, sorry, 3 minus negative 4. So that's just going to be equal to 7 because we subtract our b, or we subtract our a from our b. So in this case, using this interval here provided, our a value is going to be equal to negative 4 and our b value is going to be equal to 3. So 3 minus our negative 4 is equal to 3 plus 4, which is just going to be equal to 7. So we can say that change of x is going to be equal to 7 over n. Next, what we want to do is find that f of xi. Let's start with xi. So xi is just going to be equal to our a value of our interval plus change of xi. So in this case, since we said that negative 4 was our a, xi is going to be equal to negative 4 plus 7 over ni. And from here, we just want to plug in this xi into our function so that we can have f of xi. So f of xi is going to be equal to plugging in just this xi in for our x. So negative 2 times negative 4 plus 7 over ni minus 2. So from here, we can actually simplify slightly, simply distributing this negative 2 into both of these terms here. So we can say that f of xi is actually going to be equal to positive 8 minus 14 over ni. Again, simply just multiplying a negative 2 into each of these terms on our xi. So now that we have that, we're going to have that negative 2 still from our function f of x. So this is going to be equal to f of xi, but we can actually continue to simplify this further by subtracting this negative 2 from this positive 8, as they are just those like terms. So we can actually go ahead and say that f of xi is actually going to be equal to 6 minus 14 n over I, or 14 over n times I. So that will be our f of xi. And from here, we just want to plug in these two things, f of xi and change of x, into our limit definition. So doing so, we'll look a little something like this. So limit as n approaches infinity for the summation of 6 minus 14 over n times I, and then times our change of x, which is just going to be 7 over n. And from here, our next step will simply be to simplify and to solve our limit. So what we want to do first is actually just distribute the summation to each term that we have present. So limit as n approaches infinity for the summation of 6, and then minus the summation of 14 over ni, and then both of these times 7 over n, which is our change of x. From here, we can actually simplify it even further, pushing out this 14 over n constant out, so that we can further simplify. So this right here will be equal to limit as n approaches infinity for the summation of, actually let's not do summation, let's just write it out simplified. So this summation of 6 is actually just going to be equal to 6n, as the summation of the constant 6 n number of times is just going to be equal to 6n. From here, we can do minus, and again we pushed out that constant outward out of our summation here, and then we're going to have times the summation of, so we're going to have 14 over n times the summation of I. We can replace this summation of I for this term here of n squared plus n over 2. So that'll look a little something like this. So that'll be what we have left is just this right here. So from here, we can actually just continue to solve, combining these two terms here. So we're going to have limit as n approaches infinity for 6n. And actually remember that we still have that 7 over n times this whole thing. So it's important to note that and to not lose track of that as well. So multiplying these two once again out is just going to give us 14n, as these two n's on the top and the bottom will cancel out, and then over 2, and then plus 14 over 2. Again, just multiplying this 14 over n times this n squared plus n over 2. So it'll give us just these two terms here. And what we want to do next is actually just multiply in our 7 over n that we had. So from here, what we're going to end up getting is just going to be the limit as n approaches infinity for, let's see, 6 times 7 is going to be equal to 35 over n squared minus, and then multiplying again the 7n times that 14. So 14 over 2 simplifies, is just going to be equal to 7n. 7n times 7 over n is just going to be equal to 49, as that 7 over n times that, or not that 7 over n, that's 7n over 1. So that's 7n times that 7 over n is just going to be equal to 49 n over n. These n's will cancel out, giving us just that 49. So that is why that is. And next, moving on to this next one, we're going to have plus 14, or again, simplifying that 14 over 2 to just 7. 7 times 7 over n is going to be 7, or 49 over n. And that'll be when we multiply the 7 into these two. So what we want to do from here is simply just simplify. And actually, it would appear that we did this first term wrong, actually, as a matter of fact. So let's redo this one. Because this is going to be equal to 6n over 1 times 7 over n. These n's will cancel out, giving us just a 6 times 7 value, which should be equal to 42. So this is actually going to be 42 right here for this term. And then we have minus, and then minus these parentheses. So from here, what we want to do is actually just plug in our n approaching infinity limit that we now are able to plug in. So we're going to have just 42 minus 49 plus 49 over n, which is equal to, or is going to be approaching infinity, so 49 over infinity. This 49 over infinity is just going to cancel out into a 0, as any number divided by infinity is going to be approaching that value of 0. So we don't even have to write anything right there, as that's just going to be equal to 0. So we're going to have 42 minus 49, which is going to be equal to negative 7. And that should be the answer that we end up getting for our limit. And if we were to integrate this in another way, we should get the same answer. So if we said negative 7, if we would just go ahead and integrate normally to check our work, let's actually go to Desmos here to check our answer of negative 7. So we said the integral from negative 4 to 3 of the function negative 2x minus 2 dx, and we said negative 7, and it is indeed equal to negative 7. So that would be how we solve for these integrals, simply using the definition of an integral, and we can see that we arrived to the same answer as if we would have derived normally, or if we would have just plugged it into a calculator. We still get that same value of negative 7. So yep, that is how you do that.